All right, guys, let's knock out this test 10 review for you real quick. Gonna apologize real quick. All I have with me is an Apple Pencil, so you can hear a lot of clicking on the screen. Not much I can do about that. Like, there's one right there. Okay, so number one says find the reference angle for each angle. Remember, reference angle is how far away your angle is from the x-axis. It's got to be acute. 225 is 45 away from 180, so it's 45 degrees. Negative 199 is 19 degrees away from 180, so it's 19 degrees. Remember, if it's radians and you have a pi, you can just drop the top. If it's a power 2, power 3, power 4, power 6. The other ones you got to kind of figure out. The nearest whole pi is what you need there. Number 2, find the exact value. 210. 210, the reference angle would be 30. Everybody knows cosine 30. Remember, that's the x coordinate. Cosine 30 is square root of 3 over 2. Because 210 is in quadrant 3, that means that value is negative. Sine 7 power 3, I'm really just thinking power 3. Sine power 3 is also square root of 3 over 2. 7 power 3 is in quadrant 1, so it's positive. Secant 300, 300 is 60 away from 360, which means the reference angle is 60. And I'm doing cosine. Cosine of 60 is a half, which means secant 60 is 2 because it's reciprocal. 300 degrees is in quadrant 4, and because cosine is positive in quadrant 4, so is secant positive in quadrant 4. And part D, cosine negative 5 power 3. Act like it's just power 3 first. Cosine of power 3 is, of course, 1/2. And then negative 5 power 3 puts you in quadrant 1. Cosine is positive in quadrant 1, so it's positive. Number 3, write tangent in terms of cosine, and it's in quadrant 3. Okay, so tangent is really a sine over cosine. So what I've got to do, I've got to write tangent in terms of only cosine without the sine. So what I remembered is this right here. Remember our identity from the other day, sine squared plus cosine squared is 1, which means sine squared would be 1 minus cosine squared. So to get sine, I would take square to both sides. So that's what I'm going to put here. Sine is really plus or minus square root of 1 minus cosine squared. That's what sine is, and that's over cosine. Right now, because it tells me quadrant 3, and it says cosine is in quadrant 3, that means my cosine's negative, or my sine's negative instead. So I'm going to change that plus or minus and just put a minus right there. And there is tangent in terms of only cosine in quadrant 3. All right, number 4, write secant in terms of sine. All right, so I'm going to go back to that first thing I just did. Sine squared plus cosine squared, I forgot the S, is 1. And the reason I'm doing this way is because secant is reciprocal of cosine. So what I'm going to do is I'm going to solve this for cosine and then just do the reciprocal. So that means cosine squared is going to be 1 minus sine squared, which if I take the square root of that, I get cosine is really plus or minus the square root of 1 minus sine squared. So that's cosine. I need secant. Secant, I'm not running out of room here. Let's see if I can make this a little bigger. So that would give me secant, which is reciprocal of cosine, would be the reciprocal of the other side. So secant is, that's in quadrant 1, by the way, also, which means the cosine is positive. So I'm going to do a positive square root of 1 minus sine squared. And this is going to be one case. I think I'm going to let you leave that radical on the bottom instead of rationalizing it. It'll let me one more step, but I think we're fine leaving it there for now. Number 5, find the values of the trig functions if secant is 5, and also says sine is negative. Secant is 5, that means cosine is 1/5. All right, and it's positive because secant is positive. Okay, now, if it's 1/5, I'm about to do sine squared plus cosine squared is 1. Okay, cosine squared, because cosine is 1/5, that's going to be 1/25. That's going to equal 1. So sine squared would be, I'm going to take that over, would be 24/25, which means sine, it already tells me it's negative. So instead of putting plus or minus, I'm just going to put a negative. If you break down 24, you get 2/16. If you break down 25, you get 5. So there's my sine. Sine theta, negative 2/16 over 5. Okay, Miss Beth just walked in. Kind of messed me up there. I hit pause, so you probably didn't hear her. Okay, cosecant theta is reciprocal of sine, so I'm going to flip this one, negative 5 over 2/16. Remember, take the square root to the top. Take it out on the bottom. When you take that 6 out and multiply by 2, that gives you 12 down there. Tangent. Now the best way to do tangent is do cosine, sine over cosine, all right? Sine, and their denominators cancel. Look at my sine, look at my cosine. Sine would be negative 216 over just 1. I don't know why I put a 5 in there. 6 over 1, which is just negative 216, which means the last one, cotangent, you would just flip that, make it negative 1 over 216, move your radical to the top, take it out on the bottom. There you go. There's all 5 values. It's a good question. Number 6, find the area of the triangle with sides 8 and 10, included angle 72. We got a little formula for that one. And remember, the angle must be included to do this. We're going to say 1/2 times the 2 sides times sine of the angle. And you can punch that straight into your calculator. Okay, I just punched it in. I got like 38.04 for my area of the triangle. All right. Number 7, starting review now. Number 7, got exponents everywhere. Oh my gosh. So let's work inside out here. I'm going to leave the 2 outside for now. I'm going to take that negative 3 and apply it to everything inside. So I'm going to get r negative 3 s12. Remember, when you raise a power to a power, you multiply. On the bottom, I still have r squared s squared. I'm still going to work inside. Look at my r's. I'm going to take this r down there, make it r to the 5th on the bottom. The bigger s is on the top. It's 10 bigger. That's squared. Now, again, power to a power. So I'm going to go s20. 10 times 2, r10, 2 times 5. That's it. Don't think you can reduce those exponents. You can't reduce exponents because you think you can. They're the exponents. All right. Let me double check that real quick. All right, I think it looks good. Okay, number 8, couple more here. Determine the function is 1-to-1. Remember, to be 1-to-1, it must pass the horizontal line test. Now, the graph of this one is going to go up 3 because it's got the 3 right there. It's a cube, which means it's half a parabola up, half a parabola down. Does that pass the horizontal line test? Heck yeah, it does. So you just put yes. Number 9, determine whether it is even, odd, or neither. One thing I know for sure, it is not even because the exponents are odd. Remember, because the exponents are odd, you can't say it's odd, but you can say that it is not even. The way you test odd is you plug in a negative y, which I'm doing over here, and a negative x, where the x's are. You got to plug in both negative x and negative y because you're checking for origin symmetry. You could also graph it and see if it has origin symmetry. Remember, you can turn your calculator upside down, see if it looks the same way. So this side is this, the other side, because the cube will not change it to positive, it goes to negative. The 7 won't change it either, it goes to positive. So this is what I get when I plug in a negative x and a negative y. What you got to ask yourself is 2 things. Is that exactly the same as I started with? No. Is it exact opposite? Yes, which means it's odd. If either one of those is true, that's it. Or once again, you could take it, punch in your calculator, check for origin symmetry. Number 10, find the length of an arc, the subtends, that's our favorite word, a central angle of 45 degrees. And this is my formula for the arc length and radius and theta. Remember, this only works if you have a radian. So I'm going to take this 45 degrees first, change it to radians by just dividing and putting pi with it. So it's going to give me pi over 4. So that's my angle, pi over 4. My s, arc length is what I'm looking for. My radius is 12. Cross multiply. 12 pi is 4s. Divide by the 4. It should give you 3 pi meters for the arc length. Find the inverse. Inverse, we have a couple steps here. You take your x's and y's and switch them. So I'm going to put the x over here. I'm going to put the 2 y's over here. Now, about 3 steps here. First thing, I have a fraction bar. You got to cross multiply. So I'm going to do x times the y plus 2, which would be xy plus 2x. Y minus 2 times 1 is just y minus 2. Okay, I'm going to get my y's together and my non-y's together. So I put the xy minus y. And on the other side, I got a negative 2x minus 2. Factor out the y. That's the key step right there. Factor out the y. That leaves an x minus 1. Negative 2x minus 2. Now, because it says y times x minus 1, the opposite of times is divide. So I'm going to divide both sides by x minus 1. On the left-hand side, I just cancel. So there's your answer right there. Except remember what we always do. We always take out that y and replace it with the inverse of f of x to make it look good. I don't know if you saw the email come through or not. Number 12. Which intervals is it increasing or decreasing? Remember, decreasing, it's going down from left to right. Increase is going up. So I'm going to put increasing first and decreasing, even though the graph actually decreasing first. Now, don't forget also when you're doing this that you're using your x coordinates only. right? So my x's, that's -3, that's -2. So it's decreasing from -3 to -2. It's also decreasing from -1 to +1. It's also decreasing from +2 to +3. Bunch of decreasing. It's increasing from -2 to -1, which is right there, by the way. It's also increasing right here, which is 1 to 2. Okay, so again, make sure you use x coordinates only. Almost there. Solve x is 6 minus 4x cubed minus 12 equals 0. Anytime your first exponent is twice as big as your first, or your middle exponent is half as big as your first, I said that backwards. Your first exponent is twice as big as the middle one, or your middle exponent is. So anyway, after blowing that up, you're going to use u. U is always the middle exponent. And again, you can do this when the middle exponent is half the first. I think I messed that up. Okay, so if we're at c and x, I'm going to put a u. I'm going to put a u squared because that's twice as big as the middle x. A u there and a 12. And I'm going to factor it. Okay, so I'm going to go -6 and +2. That gives me u is 6 and -2. Remember what I said here? Nobody cares about u. So I'm going to put the x cubed back in. X cubed is 6 and x cubed is -2. And just take the cube root of each one. The cube root of 6 is cube root of 6. The cube root of -2. Guys, this is okay to have the cube root of a -2. Now if it's a square root, obviously, different story. You have to use your eyes and stuff like that. Finally, the last one, number 14, just says factor. Always start with GCF. I'm going to take a 2 out first, which leaves me an 8x cubed minus 1. Phone's ringing. Hang on just a second. All right, then if you're looking at those parentheses, we have that our favorite cube thing in there. So I'm going to go small, big, cube root, square the first one, multiply together, change the sign, square the second one. There's the whole factor. Don't lose the 2 in the front. Don't lose it. All right. Hope that helps. See you tomorrow.